everyone, so today we are going to learn how an alkene can be converted to alcohol. So in this video we use 3-methyl-1-butane, 1-butene, and we get a final product of 2-methyl-2-butanol. So our first step is the formation of carbon cation, right? The protonation of alkenes. As we see in this 3-methyl-1-butene, we get a double bond here, and a double bond consists of a pi bond and a sigma bond. So the pi bond in the double bond acts as a nucleophile that will donate electron. And then we look at the H2SO4, the sulfuric acid. The sulfuric acid in this case acts as the acid catalyst. Look at the sigma bond between the hydrogen atom and the oxygen atom. The oxygen atom acts as the more electronegative side, while the hydrogen atom acts as the more electropositive side due to the difference in electronegativity. So in this sigma bond, later on the electron in the sigma bond, we call sigma electron, will be pushed to the more electronegative oxygen atom. And the more electropositive hydrogen atom will act as the electrophilic side. So now the pi electron attack the more electropositive H atom in the sulfuric acid to form a 2' carbon cation. The hydrogen atom will always attach to the carbon with more hydrogen atom. For example, in this, originally here we get a CH2 and here we get a CH. So CH2 has more one hydrogen atom than the CH. Thus the H from the sulfuric acid will be attached to the CH2 to form an alkyl group. And the positive charge will be located on the CH, which is the 2' carbon. The 2' carbon cation is more stable. It's more stable than the 1' one. Then the 1' carbon cation, and we get a HSO3 anion. So after we get a 2' carbon cation, our step 2 is rearrangement. 1,2 hydride shift occurs to form a more stable 3' cation. The H at here is shift to the just one with the positive charge. So now the positive charge move to the tertiary carbon to form a 3' carbon cation. So our step 3 is the formation of protonated alcohol by adding water. So in this case, the water acts as the nucleophile side that will donate electrons to the tertiary carbon, which have the positive charge. So the water molecule attack the 3' carbon cation and form a new carbon-oxygen sigma bond, and the electron pair is come from the water. So now the positive charge is transferred from the carbon to oxygen, and we get a protonated alcohol. And now we come to the final step, the deprotonation of the protonated alcohol. In this final step, a hydrogen atom is extracted from the positively charged oxygen to form our final product, the 2-methyl-2-butanol. The HSO4 anion is a base that attacks the H atom on the positively charged oxygen atom. Then the HO bond breaks and the electrons from the sigma bond are pushed to the oxygen atom. Thus the lone pair is get back. So now the positive charge is no longer exists. So we get a final product of 2-methyl-2-butanol. And as the sulfuric acid is a catalyst, it doesn't undergoes any reaction to form a new product. We get back the sulfuric acid at the end of the reaction. That's how an alkene is converted to alcohol.